Okay, so find all the zeros of this function. This is the one I've got, that function. Enter the zeros separated by commas, blah, blah, blah. Okay, I updated the notes. I can't remember if I sent you the new one. I updated them on the website. Here they are. So the exam, let me grab the exam 3 notes. I added a little bit more to them. Here they are. Oh yeah, no, I probably didn't send you the new. So you might want to check those out. The exam 3 notes are updated. There's more there now. They're kind of growing. So here's the exam 3 notes as far as finding all the zeros of a function. Put that right there for you. I'll move this up. And that's what we need today, yeah. Okay, so let me put these in here for you. So the exam 3 notes, there we go, boom, and boom. Okay, so the exam 3 notes. How do you do it? How do you find all the zeros of a function from the exam 3 notes? Well, first off, you have to graph the function at geogebra.org. Observe 1, 0, where f of x hits the x-axis. On the exam, you cannot use GeoGebra, so I will just give you one of the zeros automatically. And then you perform synthetic division for that first zero right here. Get your answer, which will be an x-squared equation. Now solve the rest with the quadratic formula. Plug into the quadratic formula, get your other 2 answers, and there it is. All right, let's go through it. It's all in the notes. So first thing we're going to do, step 1, we're going to go to Geogebra.org, which is a mix of geometry and algebra. Geogebra.org is an excellent, free and excellent website. And we're going to graph your function, graph at f of x, find at least 1, 0. You can take back more than 1, but at least 1. On the exam, I'll just give you 1 because you can't be going to other websites. All right, so I'm going to do that right now. I'm going to go to GeoGebra myself. Geogebra.org. There we are. Start the calculator. I'm going to type in the function right here. Mine is 9x to the 3rd power. So to do powers, you got to hit Shift 6, Shift up arrow. Whoops, 9x to the 3rd. Then you got to hit right arrow after that to come back down to the main line. Plus 24x, again, Shift up arrow, squared. See, if I type up here while I'm up in the power zone, it's just, I'm in the power zone. I got to get out of the power zone. So you hit right arrow or tab, and you'll go back down to the main line. Plus 16x plus 8 is my function. Just hit enter. Boom. And there it is. It graphs it. We're looking at it. There it is on the screen. You can shrink it down, expand it, whatever you want. Move it up and down. So there it is. I'm looking for a 0. Well, you see one right there at -2. You can click on it. It tells you root, same as a 0, -2, 0. So that's good enough. That's all I need is that 0. In fact, look, that's the only 0. Careful now, that's the only real 0. But what turns out is the other ones are going to be imaginary. They're going to have I in them because they're not real. Look, you're looking at the graph with me. There's only one real place the graph hits 0. This is the only point that has a height of 0. That's the only real 0, but we will find 2 other zeros that are imaginary. How do I know? Because it's 3rd power. Whatever the power is, that's the total number of zeros. Some of them may be imaginary. In this case, we've only got 1 real 0 here at -2, and the other ones, the other 2, are going to be imaginary when we do the quadratic formula. We'll get imaginary I answers. So let's go to it. So that one was, it was -2, right? That was -2 for mine. Okay, so we got x equals -2 is the only real 0. X is -2 is the only real 0. Okay. So what do you do now? Step 2, you do the synthetic division. So you say, okay, division time. I'm going to divide here. Oh, whoops, I didn't have a tool on. So I'm going to divide. Okay, and then you grab the coefficients of f of x. So grab the 9, and then the 24, and then the 16, and then the 8. And you can go ahead and just box off that last part. It's going to be the remainder. Last one's always remainder. So I just grabbed those coefficients, right? That's f of x up there. Okay, and now x equals -2. You just put that right out here. Just like that. X is -2. Kind of scribbled that up, didn't I? Try that again. There we go. Okay, remember how this works? You bring this down, and then you multiply. And write the answer right there. You multiply. Let me put that up here. Multiply. So -2 times 9. -2 times 9 is -18. Then you add these. 24 minus 18, what is that? 6. 6, and then you do it again. You multiply and write the answer right there. Multiply -2 times 6 is -12, and then you add them up. Remember this? And so that's 4. And then the last one's guaranteed to be 0. Just a good double check you haven't messed anything up. -2 times 4, -8. See that? And then when you add these up, 0. That should always happen. You should always get a 0 remainder. Why? That proves this is really a 0. It really goes in there. It's really one of the factors. Because remember what we learned in the last, a couple sections ago, is that when you have a function like f of x, that f of x is going to be x minus -2, right? It's minus each of the zeros, times what? Well, then times this. This is going to be 9x squared plus 6x plus 4. See, we've just found we've begun to break down the function f of x. Now, how do you know that's the truth? Well, think about it logically. We just took f of x right here, right? This is f of x, as these 4 arrows show, right? This is f of x. And we just divided it by this, which is x minus that number. So we just divided by x minus -2. And so when you divide, we just divided f of x by x minus -2. When you do, you get this. That's what we got. 9x squared plus 6x plus 4. So that's what's going on here. The function f of x is x minus the root. You always go x minus 0, 1, each of the zeros. And now we got to break this part down to find the other 2 zeros. Here's the first 0, which we already saw from the graph, -2. And then we got to find the other 2 zeros. How do we find the other 2 zeros? Well, we got to do the quadratic formula, A, B, C, because we're trying to find out what sets this part equal to 0. What makes that 0? So we've got to do the quadratic formula. So let's do that now. Quadratic formula, remember? -b plus or minus square root b squared minus 4ac all over 2a, which is -b plus or minus square root b squared minus 4ac all over 2a. Okay, let's plug them in. So a is 9 here, b is 6, c is 4. It's this is -b, b squared minus 4 times a times c all over 2a. Okay, and so what does that equal? -6 plus or minus squared. 6 squared is 36 minus, and these multiply, whatever, use your calculator. I'm getting 144 over 2 times 9 is 18. So that's a -6 plus or minus square root. Subtract those. And I've got minus 108 over 18. See, there it is. There's the negative. Remember what negative inside of a square root means? You throw out an I. Remember that? Right to the front. We've done with that before. So whenever you have a negative inside of a square root, that's imaginary. You try it in your calculator, it's air. You can't take the square root of a negative number. How could you? What times itself is ever negative? Nothing. It's imaginary. It's not real. So then what do we get? Oh, and then we got to break down the square root of 108. How do we break that down? Just do a factor tree. 2 times 54, that's 6 times 9, 2 times 3, 3 times 3. So I broke down the 108 into all those little pieces. So this becomes negative 6 plus or minus I now, square root. And then the 108 is all this stuff, which is what? 2 2s, right? 1, 2 2s, and 3 3s. All over 18. So I broke down the 108 right there. Okay, then what do you do? Well, square roots are a 2-for-1 deal. 2 2s inside sends 1 2 outside, and they're gone. 2 3s inside sends 1 3 outside. They're going to multiply right in the front of the root, just like they were multiplying inside the root. So this ends up becoming negative 6 plus or minus, that's going to be 6I root 3 all over 18. Is this good so far? To see what's happening there. I broke down the 108 into all his little pieces, and then it's a 2-for-1 deal. That's what square roots always do, right? You know that. Square root of 9 is 3. And what was in that 9? 2 3s, huh? See how they just did 2-for-1? That's what square roots always do. They always do 2-for-1. So when I broke down the 108 into all his little pieces here, then 2 2s in, ship 1 2 out, 2 3s in, and that leaves 1 3 left over inside, doesn't it? And this is 2 times 3 is 6 on the outside. Okay, so then what do you do? Well, then now separate these. So you get minus 6 over 18 plus or minus 6I root 3 over 18. Just separated it into 2 fractions and then just reduce those fractions. So I can just say, okay, 6 goes into 18 3 times, 6 goes into 18 3 times. So I get minus 1/3 plus or minus I root 3 over 3. Those are the 2 other zeros. The plus and the minus means there's actually 2 options here. So putting it all together, what are the zeros? Well, the first one was negative 2, right? Wants us to find, enter the zeros separated by commas. So the first one we found is right here. That's zero number 1. I called it Z1. Negative 2. That was right on the graph. Negative 2 is the only real zero. Negative 2. So I go, okay, negative 2. You can write these in any order. And then negative 1/3 plus I root 3 over 3. And then negative 1/3 minus I root 3 over 3. There they are. See how these two are imaginary? They both have I in them. They're not real zeros. This is the only real zero. As we saw on the graph, there's only one real place where the graph has a 0. So what's the process again? You graph the function on GeoGebra, find 1 0, and then do synthetic division, because you divide out that 0 to find what else is there, right? Because the function is got that 0, which always means x minus the 0 in parentheses, as we learned earlier. Then what remains when you divide by the negative 2, the part that remains, and that's why it's 0 remainder, it goes in perfectly with no remainder, but this part is the quotient that's left over. Then you do that with the quad, and you find the other 2 zeros. There we go.